All right, please confirm if my screen is visible there now.
Yeah, it is.
Okay, so balanced forces are acting on a moving body. What happens to the direction of movement and to the speed of the body? Forces are balanced. Forces are balanced. That means acceleration is zero. Resultant force is zero. That means object is at rest or object is moving at constant speed. ठीक है? Constant speed. Speed will not change. So, अब speed will not change. Why? Because forces are balanced. Forces are balanced. And if forces are balanced, then unbalanced forces can only change direction, it can change speed, it can change shape, size, right? So if the forces are balanced, that means the direction of movement does not change as well. Direction of movement does not change as well. Got it? ये बात समझ आ गई? ठीक है? So जब forces balanced होंगी, न speed change होगी आपके पास and न ही direction. ठीक है? A body slides down
Mhm.
a frictionless slope, as shown. As the body passes on the surface pushes back on the body. The force of the surface on the body is sometimes called reaction force. Force on the body is sometimes called the reaction force. In which direction does the reaction force act? I told you हमेशा reaction force surface के साथ 90 degree पे होती है. If this is your surface, then the reaction force should be acting 90 degrees to the surface.
So it's C.
Very good. If this is the if this is the surface, then reaction force should be acting like that. Okay. If this is the surface, then reaction force should be acting like that. 90 degree to the surface. If this is the surface, the force should be acting like that. 90 degree to the surface. 90 degree to the surface. So C is the answer. उसके बाद है student kicks a ball horizontally along the ground. As he does so, his foot applies force to the ball. At the same time, the ball applies a force to his foot. अब देखो कौन सा लॉ हो गया यहीं से समझ आ जाता है. Third law. How does these forces compare? So the force on the foot is equal. The force on the foot is equal. Okay. I guess the force on the foot is smaller. Smaller. Okay. Is it fine now? Or still lagging? Lenta? Vadha? Hina? Oh, sorry. Vadha? Is
Uh,
it is it still lagging?
yeah, uh,
Wait,
yeah, it,
wait. Let me
yeah.
change the connection. Just wait. Hotspot is the best solution at times. All right. Clearly audible now?
Yeah, you are audible now.
Okay. So my screen को दोबारा share कर लेता हूँ. All right. Is the screen visible too?
Yeah, it's visible.
All right. So the
Wait, can
force on,
you read the question again? Because
yeah, yes,
voice is
I
lagging.
will. I will. A student kicks a ball horizontally along the ground. As he does so, his foot applies a force to the ball. At the same time, the ball applies a force to his foot. How do these forces compare? Recording का option देखो, record हो रहा है. Okay. The force on the foot is equal to the force on the ball. The force on the foot is equal to the force on the ball. The force on the foot is smaller than the force on the ball. Smaller cannot be an option for Newton's third law, right? So A or B में से कोई है, and it cannot be in the same direction. Same direction वाला option भी गलत हो गया. So the only option left correct is A. Force on the foot is equal to the force on the ball and in the opposite direction. A sphere of mass 80
The
kg.
third law,
Yeah,
the both force applying to each other are equal, right?
yeah. They are equal, but they are not acting on the same body.
Yeah, okay, I think.
So a sphere of mass 80 kg accelerates down a slope at 2 meters per second square. So acceleration is given to you. Gravitational field strength is 10 newtons per kg. Now you will be using 9.8. Okay, but for the questions where 10 is given, you have to use 10. What is the weight of the sphere and the resultant force on the sphere? So so force आपके पास 80 mass 80 kg, right? So weight would be equals to mg, that is 80 into 10, that's 800. Sorry, 80 into 10. So weight कितना हो जाएगा बेटा? 800. Weight हो जाएगा 800. Resultant force is what? F is equals to ma. F is equals to ma. 80 into 2, that's 160. Got it?
Yeah, I got it.
Yeah.
Newton's third law involves two quantities which are equal in size, opposite in direction. What is the unit for these two quantities? जी बताओ. कौन बताएगा ऑनलाइन में से? पार्टिसिपेंट्स चेक करो.
Is it C?
ओके, अब्दुल्ला आप बताओ. लिंता, Zainab, is Zainab there online?
I think it is C.
C, it is. Vada, good. All right. Metal ball of mass 0.3 kg and weight 3 Newton is held so that it is below the surface of the oil. It experiences an upward force of 0.3 newtons. So upward force is 0.3 newtons, mass is 3 kg, weight is 3 newtons. When the ball is released, what is the initial acceleration? Initial acceleration is the acceleration of free fall. Acceleration of free fall. That's 10 in previous syllabus and 9.8 in the new syllabus. All right. Initial acceleration क्या होगी बेटा? Acceleration of free fall, gravitational acceleration. So 10. All right. A man pushes a heavy box along the ground. A force acts between the man's hands and the box. Another force acts between the man's feet and the floor. Which direction do these forces act on the man? On the man. यहाँ पर this man is applying a force on the box, right? So this is the direction of the force that the man applies on the box. And I will draw arrow arrow of the force which acts on the man with red. So this would be the direction of the force on the man from the box. Let's see. Okay. अगर मैं इसकी feet की बात कर रहा हूं तो does his feet push back on the ground?
Wouldn't it be 9 for the last one?
No, it's saying initial acceleration. Acceleration right in the beginning. Right in the beginning.
How is it 10?
That's acceleration of free fall, na? Acceleration of free fall. Acceleration due to gravity. Acceleration due to gravity.
Oh, okay, got it. Okay.
G. इसमें इसमें फॉर्मूला की जरूरत नहीं है, फैक्ट है। अच्छा, आपने फॉर्मूला क्या अप्लाई किया बताओ? वेट क्या किया था? क्या फॉर्म mg? किसको? जी निकाला यहां से। हाँ तो वो तो आपके पास जी आ गया ना, जी इज 10 देन। अच्छा, आप क्या कह आप कोई फॉर्मूला कह रही थी, वो बता।
Acceleration it is equal to F over M.
एंड व्हाट इज एफ?
Uh, it's 3.1 and 0.30 over 0.30.
Okay, upward force is 3, 0.3, right? And downward force is 3. So 3 minus 0.3 divided
Yeah,
by 0.3. So that will make it
yeah.
what?
It made it
2.7?
9. Well,
Over
I did 0.30.
0.30. Why? 3 minus 0.3 will make it 2.7, no? Getting my point? Hello?
Okay, got it.
All right. So I was on this question. A man pushes a heavy box along the ground. Force acts on the man's hands and the box. Another force acts between the man's feet and the floor. In which direction do these forces act on the man? So I told you that this is the force by the man, right? This is the force by the man. So the ground will push on the man's feet in this direction. This is the force on man. This is the force on the man. All right. So force on man's hand will be to the left. Is it? Because
Yeah.
Newton's third law, the forces are equal and opposite. Equal and, so agar force the man is pushing the box to the right, the box will be pushing the man to the left. So force on the hands is to the left. It cannot be to the right. And then on the feet, it's to the right.
Yes, it's B.
Which situation is the resultant force on the body equal to 0? In which situation is the resultant force on the body equal to 0? Where is the resultant force 0?
C, a train is going straight hill at constant speed in a straight line.
For resultant force to be 0, speed should be
Constant.
constant. And it should be moving in a straight line. Direction should not be changing. Let's see. Right? Car turning around a corner, constant speed तो है, लेकिन turn कर रहा है. Turning is due to force. So ये नहीं हो सकता. Fall कर रहा है on the moon, तो नहीं हो सकता. Accelerate कर रहा है, तो force 0 नहीं हो सकती. सही है? क्योंकि आपके पास रिजल्टेंट फोर्स अगर जीरो होगी तो एक्सेलरेशन भी जीरो होगी, स्पीड कांस्टेंट होगी। स्पीड क्या होगी? कांस्टेंट। ठीक है। ए में स्पीड कांस्टेंट अकेले नहीं ना, अकेले स्ट्रेट लाइन में भी होना चाहिए। टर्निंग, टर्निंग अगर हो रही है तो इसका मतलब फोर्स जीरो नहीं है। ओके। Four of the gravitational forces that act between the bodies in the solar system are described below. The force on the moon due to the earth is P. Force on the moon due to earth. The force on the earth due to the sun. The force on the earth due to the moon. The force on the moon due to the sun. So इसमें से कौन से दो स्टेटमेंट्स न्यूटन्स थर्ड लॉ के पेयर बनाते हैं? R and S. Force on the earth due to moon. अच्छा, और S में है फोर्स ऑन द मून ड्यू टू सन। सो इसमें बॉडीज तो दो होनी चाहिए ना, तीन बॉडीज तो नहीं होनी चाहिए। आप जो स्टेटमेंट सेलेक्ट करो ना, उन स्टेटमेंट्स में दोनों बॉडीज एक जैसी होनी चाहिए। मतलब अगर मून और अर्थ है तो दूसरे स्टेटमेंट में भी मून और अर्थ ही होना चाहिए, ये नहीं कि उसमें मून और सन बन जाए।
But
बॉडीज
like
शुड बी
there's
टू ओनली।
so it's like P and R because the force on the moon due to the earth
यस,
and the force on earth due to the moon.
ऑन द मून ड्यू टू अर्थ, ऑन द अर्थ ड्यू टू मून, ऑन द मून ड्यू टू अर्थ, ऑन द अर्थ ड्यू टू मून, on the moon due to earth, on the earth due to moon. तो reverse हो
Can you
जाता है,
explain it
right?
again, please?
I'm saying for Newton's third law, we know that the forces are two. Forces are equal. The forces are opposite. The forces act on opposite bodies. So when forces act on opposite bodies, there are only how many bodies? Two bodies that they can act on. ठीक है, बात समझ आ रही है? तो न्यूटन के थर्ड लॉ पेयर में आपके पास दो बॉडीज होनी चाहिए। Getting the point? If body
Yeah,
is
get it.
A,
Mm.
it cannot be that body A acts a force on body B acts a force on body A. That's third law pair. Again, it cannot be like this. If body A acts a force on body B, then body B will act a force on body C. ऐसा नहीं हो सकता। ठीक है?
Okay, understood.
All right. So इसका ऑप्शन हो गया B. All right. A force acts on a body which list contains only quantities that can be changed by the force. Can mass be changed? Can mass be changed?
No.
Can mass be changed?
No.
No. So A, B, C gone. So force can change shape, velocity, volume. All right. The diagram shows two forces that are equal in magnitude. Which diagram shows forces that are Newton's third law pair of forces?
It's a normal the table to the book and the table
Uh,
table to
but
the book and book to the table.
all right, good. But this is normal force and this is weight. Weight is a gravitational force, and the normal force is when two objects are in contact. So forces are not of the same type. Forces should be of same type as well.
I think it would be B1.
अच्छा,
So I think it's B.
B की अगर मैं बात करूं तो ये फ्रिक्शन है, राइट? और ये टेंशन है। अगेन दे आर नॉट ऑफ द सेम टाइप। फ्रिक्शन और टेंशन अलग अलग फोर्स होती है। चेक करते हैं। डी की अगर मैं बात करूं so this is weight, a gravitational force, and this is air resistance, a different force. They are not of the same type. हाँ, यहाँ हो सकता है, यहाँ हो सकता है। इलेक्ट्रॉन इज अट्रैक्टेड टू न्यूक्लियस, न्यूक्लियस इज अट्रैक्टेड टू इलेक्ट्रॉन। अब यहाँ पर एक ही फोर्स होती है, इलेक्ट्रोस्टैटिक। अट्रैक्शन की वजह क्या है? इलेक्ट्रोस्टैटिक फोर्स। अगर मुझे यहाँ पर न्यूटन थर्ड लॉ पेयर बनवाना होता तो फिर क्या करता? मैं कहता weight of the table on the book. जैसे बुक टेबल के ऊपर है, let's look at it reversed. टेबल बुक के ऊपर है. The book is pulling the table up. All right? अच्छा जी. बेटा बात समझ आ गई?
Yeah, so it is A, right?
Yes.
It's D, bete. Sorry, C. Not A. Electrostatic
C.
force. C. Right? It's not A. If I.
But it's saying third law, and the third law is like both forces acting on each other.
Yes. Are equal and opposite.
So isn't
But those forces should be of
E
the same type. Contact forces होनी चाहिए अगर दोनों है ना. Weight को हटा के अगर इन्होंने लिखा होता ना, contact force. This is normal contact force from where? From table. From table on the book. Then यहाँ नीचे लिखता contact force from book on table. तो तब ये न्यूटन थर्ड लॉ पेयर बन जाता. या फिर अगर वेट को चेंज ना करना होता, वेट को आप चेंज नहीं करना चाहते, तो आप क्या करते, आप यहां से नॉर्मल कांटेक्ट फोर्स हटा देते, आप कहते द वेट ऑफ द टेबल ऑन द बुक, वेट ऑफ टेबल ऑन द बुक. गेटिंग माय पॉइंट? कांटेक्ट फोर्स तो तब होती है जब दो सरफेसेस आपस में टच कर रहे हो, कांटेक्ट में हो. तो तब आपके पास ये वाला सरफेस इसको पुश करेगा. This pushing is not the weight, it's not due to gravity. This surface will push this one. This pushing is not the weight, not the gravity. Right?
okay, got it.
So the forces have to be of the same nature, of the same type, of the same category. अगर एक force weight है तो दूसरा भी weight होना चाहिए. एक force tension है तो दूसरा भी tension होना चाहिए.
Okay, so they have to be like same type of forces acting on each other.
Yes. और यहाँ पर जो attraction हो रही है ना, इलेक्ट्रॉन अट्रैक्ट करे न्यूक्लियस को, ये न्यूक्लियस अट्रैक्ट करे इलेक्ट्रॉन को, दोनों किस वजह से बेटा? इलेक्ट्रोस्टैटिक फोर्स की वजह से.
Okay, I got it. Thank you.
All right. A man with an open parachute is falling to earth at constant speed. The following forces are acting. Upward force of the parachute on the man, parachute on the man. Upward force of the man on the earth. ये तो तीसरी चीज आ गई. Downward force of the earth on the parachute. ये एक ऑप्शन बन सकता है. Downward force of the man on the parachute. ये एक ऑप्शन हो सकता है. अब इसमें से कौन सा करें? Up PNS. So this would not be an option. ठीक है? Good. So क्या ऑप्शन हो गया? अब्दुल्ला, वधा, लिंता.
PNS.
PNS. All right. Which arrow shows the direction of gravitational force on the block? Gravitational force की हमेशा कौन सी डायरेक्शन होती है बेटा?
The A1.
A. ग्रेविटेशनल फोर्स कुछ भी कर लो ऑब्जेक्ट को ना, हमेशा वर्टिकली डाउन एक्ट करती है. अगर ये बॉक्स अगर ये बॉक्स यहाँ यूं रखा होगा ना, तब भी इसका वेट डाउनवर्ड ऐसे एक्ट करेगा. अगर ये बॉक्स आपने यहाँ उठा दिया तब भी इसका वेट डाउनवर्ड ऐसे एक्ट करेगा. ये बॉक्स उठा के यहाँ रख दिया आपने, तब भी इसका वेट डाउनवर्ड ऐसे एक्ट करेगा. ठीक है? सो इट्स ए. A hanging basket is fixed to a wall by a bracket. The weight of the basket is 80. Weight of the bracket is 20. What is the size of the upward force exerted on the bracket by the wall? 20 downward है, 20 downward है, right? But it's not falling. So इसका मतलब है upward force कितना होना चाहिए? it's not falling.
100,
सोचो ना भाई, ये 20 से नीचे खींच रहा है, ये 80 से नीचे खींच रहा है, बट ये खींच नहीं रहा, तो इसका मतलब इसके ऊपर अपवर्ड फोर्स कितनी लग रही है?
0,
मैं आपका रिस्पॉन्ड नहीं कर रहा था, आपका पहला रिस्पॉन्स मैंने सेव कर लिया, मैं बाकी लोगों का वेट कर रहा हूँ, मैं किसी और को कुछ बता रहा था। मुझे ये बताओ, टोटल डाउनवर्ड फोर्स कितनी लग रही है?
Total downward force
100,
100
100,
Newton.
and it's balanced, right? It's not moving, so what would be the total upward
Mm.
force?
There's no wait. I'll read the question again. So there's no upward force there.
There is ना,
there's
वरना
a
तो
wall.
वरना तो ये ब्रैकेट यूं नीचे स्लाइड कर जाता वॉल के साथ,
Oh yeah, the wall. Yeah, there is. Okay.
right?
Yeah.
And it's not letting it slide down, ठीक है? It's acting an upward force. And
So
how much
the
force it should be so that it does not slide?
100
100,
Yeah,
Newton.
you were right, Abdullah, at the first point. So, जो आपको सही लगे ना, do stand by it. माहौल को, environment को देख के अपने responses change कभी नहीं करना. That goes the same for practical life as well. Okay? So, आगे बढ़ते हैं. A train of mass 240,000 kg is traveling at a speed 60. The brakes are applied and it decelerates for 10 minutes. How long is it taking to decelerate? Until it comes to rest. So ये speed थी, starting speed, right? जब आपने note किया, और finally speed ये हो गई 0. हाँ? कितना time लगा इस दौरान? 10 into 60. 600 seconds लगे. कितने लगे बेटा? 600 seconds. I need average resultant force. So resultant force is what? M into A. M कितना है बेटा? 2,
sir, can I
4.
go for a minute?
Yeah.
Okay, thanks.
नमाज टाइम हो गया ना? Abdullah, you there? अब्दुल्ला ने नमाज की इजाजत दी ना, I think. Can someone tell me? Vada, was he asking for prayer break?
I don't think so. I didn't hear him.
Okay,
Sir, I came back.
all right. अच्छा, मुझे बता अब्दुल्ला, नमाज में कितनी टाइम है?
Sir, the time's up now.
है ना, टाइम हो गया नमाज का. चलो ये एक काम करते हैं, इस क्वेश्चन को मैं यहाँ पे रोक लेता हूँ, नमाज पढ़ते हैं, एंड देन वील कंटिन्यू. जमात रेडी है तुम्हारे? तो करीब होती नमाज है, तुम अकेले पढ़ते हो?
Sir, with the Jamaat.
All right. So how long will you be back in? 10 minutes? How long will it take you? 10 minutes? चलो खैर. बेटा जिन लोगों का नमाज का टाइम नहीं हुआ तो वो क्वेश्चंस कंटिन्यू करें, क्योंकि मैंने होमवर्क असाइन किया था. लेंथ आपने ट्राई किया था इसको कि नहीं?
Yes, sir, I tried the question.
Okay, you tried all of them?
Yes, all of them.
Any difficulty, any questions that you did wrong?
No, sir.
All right. तो जिनकी ये वाले क्वेश्चंस ट्राई हो गए हैं और अभी नमाज का भी टाइम नहीं है, आई थिंक वदा का भी शायद नमाज का टाइम ना हो, बाकी लोगों का तो है, तो नमाज जरा जल्दी से पढ़ लो, and I'll be back right in 12 minutes. Speaker off karo. Mic.